Good morning, everyone. Today's subject is dynamics of machinery. My name is Dharma Teja. My roll number is 20951 Today's topic is balancing of multi-cylinder engine. Introduction. A reciprocating engine is a heat engine that uses one or more reciprocating pistons to convert the pressure into rotating motion. They are used extensively in motor vehicles and power generators and aircraft. The engines using more than one cylinder are multi-cylinder engines, which are used extensively nowadays. These engines can be inline or radial. Inline engines are usually found in 4 and 6 cylinder configurations, with all cylinders aligned in one row with no offset. They have been used in automobiles and locomotives and aircraft, although the term inline has a broader meaning when applied to the aircraft engines. An inline engine is considerably easier to build than an otherwise equivalent horizontal opposite or V engine, because both a cylinder bank and aircraft and a crankshaft can be milled from a single metal casting, and it requires fewer cylinder heads and camshafts. Inline engines are also much smaller in overall physical dimensions than designs like the radial, and can be mounted in any direction. Straight configurations are simpler than their V-shaped counterparts. They have support bearing between each piston as compared to flat and V engines, which have support bearings between every two pistons. Balancing. An unbalance of forces is produced in a rotary or reciprocatory machinery due to the inertia forces associated with the moving masses. Balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level, if an possible is eliminated completely. The unbalances forces extracted on frame by the moving machine members are time varying, impart vibratory motion to frame and produced noise. Balancing of bodies is necessary to avoid noise, vibrations and harness, which could cause catastrophic failure of machinery. The most common approach to balancing is by redistributing the masses, which may be accomplished by addition or removal of masses from various machine members. There are two basic types of unbalance: rotating unbalance and reciprocating unbalance, which may occur separately or in combination. Balancing of rotating masses, static balancing and dynamic balancing. A system of rotating masses is said to be static balance if the combined mass center of system lines on the axis of rotation is called static balancing. And dynamic balancing, when several masses rotate in different planes, the centrifugal force, in addition to being out of balance also forms couple. A system of rotating masses is in dynamic balance when there does not exist any resultant centrifugal force as well as a resultant couple, is called as dynamic balancing. Primary and secondary balance. Primary balance is the balance attained to the accommodating for the eccentricities of the rotating masses, including the connecting rods. Primary balance is controlled by adding or removing masses to or from the crankshaft to each end at the required radius and angle, which varies both due to the design and manufacturing tolerance. The theoretically any conventional engine can be balanced perfectly for primary balance, and secondary balance is attained by the compensating partially or fully for kinetic energy of the pistons, non-sinusoidal motions of the pistons, motion of the connecting rods, sideways motion of the balance shaft weights. The second of these is the main consideration of the secondary balance. There are two main control mechanisms of their secondary balance: matching the phasing of pistons along the crank so that there are second order contributions cancel, and uses of balance shafts which run at twice engine speed and so can provide a balancing force. Now, theoretical analysis of balancing multi-cylinder inline engines. A multi-cylinder inline engines are used in applications where high power is required, and it gives an advantage of better balance of forces and moments. It is also provides a better and even distribution of torque out to the crankshaft shaft, and facilitates the smooth running of engine. The general configuration used two-cylinder, three-cylinder, four-cylinder, five-cylinder, six-cylinder, eight-cylinder inline engines. The six-cylinder and above configuration engines are completely balanced for forces and couples. The forces and couples for different cylinder members and firing order are analyzed below theoretically. Theoretical analysis of balancing of multi-cylinder V engines. And a V engine is a common configuration for internal combustion engine. The axial planes in which the two sets of pistons reciprocate intersect at the crankshaft axis and form a V of a engine beta. In automotive installations, V6 and V8 engines are common in both beta and either 60 degrees or 90 degrees. The 90 degrees V angle is the most preferred and generally used. Therefore, we have used beta equals 90 degrees in this analysis. The V configuration generally reduces the overall engine length and height and weight compared to the equivalent inline configuration. The general configurations used in V2, V4, V6, V8, V10 and V12. The forces and couples for different cylinder members and firing order are analyzed below theoretically. Balancing of single cylinder engine. A single cylinder engine produces three main vibrations. In the describing them, we will assume that the cylinder is in a vertical. Firstly, in the engine with no balancing counterweights, there would be an economized vibrations produced by the change in momentum of the piston, guidon pin, and connecting rod and a crankshaft. Once every revolution. Nearly all single cylinder crankshafts is inoperative balancing weights to reduce this. While these weights can balance the crankshaft completely, they cannot completely balance the motion of the piston for two reasons. Thank you for giving this wonderful opportunity.